हेलो. एक सेकेंड. Hello. Hi everybody. How are you all? The first session of differential equation got ended abruptly due to a YouTube glitch. That day, that happened on many channels. I think on Saturday we took, right? On Saturday we took differential equations. No, on Saturday though we took PYQs. Friday we took a differential equation and session got ended. Then then on Monday also we had one session. So that's why today I'm continuing with our session of differential equation. 25th, because of Christmas we had to keep an off. And so anyway, this is basically the second part of differential equations which we are doing. We ended so I'll just quickly revise what all we did before continuing. So we first of all we saw what is order and degree of a differential equation. Then we saw what is a differential equation. Then we saw how to form a differential equation. After that we started with solving the differential equation, and in this we had a few methods: variable separable form, reducible to variable separable form, which is this one. Then we'll go to linear and exact form. Like so, four forms in which we learn how to solve the differential equations. 4 different forms, very standard and very formative and defined chapter this is. You just have to learn the standard formats and the ways in which we need to solve a differential equation and be good at differentiation and integration. Nothing more than that is required. So first form, where variable separable form, where we can separate the variables, we can keep all the y's with dy and all the x terms with dx. That was variable separable form. You can refer the previous video which is on the channel only. If you have directly come to this video, in that case, first prefer the previous video, which is the first part of differential equation, then come to this. Now to the second part, reducible to variable separable form. Not always you'll be able to see, not always or in every question you'll be able to. For example, I'll show you the last question which we did. In this question we were able to keep all the y's with dy and all the x with dx, and we'll get something like this. So this is the standard variable separable form which we saw, but we'll not be able to do this always. Okay, we'll not be able to do this always. Sometimes we'll have to reduce our differential equation in the variable separable form. So that's what we are going to see here. It was very easy to do because we could separate, but sometimes we'll not be able to separate, and this is the form which will be used many times. This is something which you will see a lot of times. F of a linear function will be there on the right hand side, left hand side, or dy by dx will be equal to some linear function. And in this case there is a standard approach, substitution. See, basically if you are if you have learned substitution very well in integration, then here also you won't find much of problem, because it's going to be kind of similar only. But so you can relate, always relate. Intuitive substitutions will also work over here, because if you have studied an integration, here also you'll be able to intuitively think, acha, this is something, I think this is something we should substitute instead of as t or something, right, like that. So here also it will work. Now sometimes when you see, specifically when you see a linear function on the right side, right, linear function on the right side, substitute the linear function as t, your differential equation will reduce into variable separable form. For example, let's see this question. This is from 2020 p by q only. So you see, right side, acha, one more thing, same linear function should be there, right? Y plus 3x, same thing is here also, numerator and denominator, in both the places, same thing is there. If you see the same linear function in a linear equation and you want to reduce it to variable separable form, then just substitute your variable function as t. So basically y plus 3x, I'm going to substitute as t, right? As soon as you'll do dt by dx over here, your dt by dx will be nothing but dy by dx plus 3, right? Or I should say, yeah, same thing. dy by dx is dt by dx minus 3, or dy by dx plus 3 is equal to dt by dx, right? This is the thing which we are going to get. So from here you take this value of dy by dx and use it over here. Now what will be dy by dx from here? What will be dy by dx? Dy by dx is going to be 3 minus dt by dx. That's what we are going to substitute in the main equation. Now what are we going to get? We'll have dt by so dy by dx, right? So 3 minus, okay, we'll have 3 minus dt by dx minus, this thing is t and this will become ln of t. So t upon ln of t ln t, plus 3 and minus 3 anyway are getting cancelled. So no, are they becoming 6 dt by wait, dy by dx is dt by dx minus 3. Sorry, we did ulta kya. Dy by dx will become dt by dx minus 3. I'm so sorry. Okay, right? Minus 3 will come this side. Now we'll substitute dt by dx minus 3 minus t by ln of t plus 3. That's why I remember that these 3's should get cancelled. That's why it clicked to me that something wrong happened. Now, so here what we'll have, dt by dx is going to become t by ln of t, and here we'll be easily able to subtract, sorry, now this can be, here we can achieve the variable separable form very easily, right? Here we'll be able to achieve the variable separable form. This looks exactly like what we do in variable separable form. So dt by t we are going to have, and on the right side we are going to have dx, dt by ln of t by t dt we'll have on one side, and right side we are going to have dx. Now just integrate both the sides and we have our solution of the differential equation. So integrating both sides, this will become ln of t by t. This becomes, I think, ln of t square by 2, right? Simple standard integration. If you remember this, okay, otherwise substitution will help you. This will become ln of t whole square by 2 equal to x plus c or minus c, depending on the option. What are we getting? Acha, we'll have to substitute t back. So let's take this minus c, okay, and what is our t? Our t, we'll have to substitute t back in the solution. So ln of y plus 3x whole square by 2 it will become. Ln of y plus 3x whole square by 2 it will become equal to x minus c. Or we can keep x plus c also, won't matter, won't create a difference. Only thing is that this is given in this way, right? C is taken as positive, so I'm just taking integration constant as minus c. It won't matter, you take plus c or minus c, it actually doesn't matter much. So this is going to become half, yes, we have this option here, half ln of y plus 3x whole square is equal to x minus c. This thing, correct? Option A will be correct. So x will go that side and option A will come out to be correct. What to learn is that if you see a linear function everywhere on the right side, then you can substitute it like this. You should substitute the linear function as t directly. That's it. That's good. Okay. Yeah, option A is correct. Now, one more thing, one more form very rarely seen, but sometimes if you see y f of xy plus x g of xy. I mean, there are two functions of xy altogether. With y you have xy, and with x also you have a function of xy. With y you have a function of xy, and with x you have a function of xy. In this case, what you're supposed to do here also same thing. Xy you can substitute as something else like a t or v. Here they have used t, so let's sorry, here they have used v, so let's do v only. So just pay attention on the form. With y you have a function of xy, and with x also you have a function of xy. With y you have dx, and with x you have dy. In this case also substitution is going to help and will give you a variable separable form, right, which you want. So here we can prove this also very easily. Here only, let's solve it here only. I don't think question of this we don't have a question of this, but you will find these type of questions very rarely, but still just remember this form. With y you have dx, right, and a function of xy. With x you have dy, and there is a function of xy, right? So if you put xy equal to t, your xy equal to, let's say, t, so v or t, anything, xy, all right. So if we put like this, then we'll get x dy by dx plus y, right, differentiating both sides. This is dt, this will become dt by dx, right? Now look in this, y f of xy instead of f of xy. Now we can write f of xy instead of f of xy, f of t we can write, right? I'll directly write f of t, because we have taken xy as t, plus x g of t, wait, dx plus x g of t dy equal to 0. Correct? This is what we are going to have. Here also y will become t by x, right? Your y will become t by x. So let's put t by x f of t plus, sorry, what will dx become? Acha, dx so we cannot substitute like that, but plus x, this g of t will become for me, yeah, this is g of t only, g of t, or we can do something about dy. Wait, right, t by x we have put over here, so this will become your dt by dx minus y, right? We have dy over here, na? So this will become dt by dx minus y. We can write over here dt by dx minus y directly. Just a minute. I hope there is no, let me just verify whether I'm audible, because viewers are, if you see something like this, okay, great. uh, Audible enough, right? Hello? Hello, hello. Audible enough, right? Hello? Oh, okay. So what? Sorry for interruption. I had to check the sound because the viewers were not there. dt by dx minus y. We did y over here. Y f of t. Correct. No problem. Dx plus x g of t dy. Now x dy we can put it as dt by dx minus y. Right. Instead of dy, what we can do is, okay. First let me write the same form, plus x g of t dy. All right, now dividing by dx, this will become y f of t plus x g of t dy by dx, right, equal to 0. Now y is your t by x, right? Y is t by x, f of t as it is, plus, now dy by dx will, from here dy by dx will be dt by dx minus y. So x g of t dt by dx minus y, and 1 by x will also come over here, right? 1 by x will also come. So this x and this x is getting cancelled. Now what are we going to have? Now this will become okay, t by x as it is, f of t as it is, plus g of t will go with dt by dx, right? What else? Minus y g of t, minus y g of t. Now can we take something common from here? T by x g of t. Okay, y again will become t by x, no, over here. Y again will become t by x over here. Now I think we are getting variable separable form, right? This will simply become g of t divided by f of t. If you take common things, minus minus g of t, sorry, t of g, tg of t, this tg of t will come, and minus t f of t. You solve this taking common, minus t f of t. This is here it will come t g of t into g of t minus t f of t, right? dt will come out equal to dx by x, right? Only one x was there. Only one x was there. This will come out like this. Just check once. Right, t by x you can take common, or 1 by x you want to take common, then 1 by x with t f of t minus t g of t will come in denominator, and g of t will come in numerator. So with the dx we can do dx by, and this is what we call variable separable form, no? With all the t functions are with dt and x function is with dx. So if you get, good afternoon Jimmy, if you get a situation like this where you have dx with y, dy with x, and there are functions of xy involved, just simply substitute xy as t or v or something, and then put your approach like this, right? Similar approach you can go with. Here we proved this, or that it will reduce to variable separable form, because we can see, and it will always happen. Just substitute xy as some t or v, and you'll be able to achieve this, because this particular differentiation is going to be substituted here everywhere, and it will separate all the v functions with dv, or sorry, here we use t, so v functions with dv and x functions with dx. Basically you'll achieve the variable separable form. right? No problem. Hi Karthik. कोई बात नहीं, no problem. Homogeneous differential equation. Next thing is homogeneous differential equation, which is very common and frequently, or we can say in boards or in your school also, you'll get to see questions based on homogeneous differential equation, and it's very easy to understand what do we mean by homogeneous differential equation. Homogeneous differential equation basically says that instead of x everywhere if you substitute tx, instead of y everywhere you substitute ty, let's say, then when you write the expression, your entire expression again, from everywhere t will come out and t will get cancelled also, and you'll again get the same function. We'll understand with the help of examples. The definition, first of all, f of xy is said to be homogeneous expression of degree n in variables x and y if in the same function, on putting instead of x you put tx, instead of y you put ty, and you receive the same function again. It can be multiplied with t to the power something or some, all the t will come out common basically. Great, Jimmy, great. So let's check for these functions. Let's say this is our function f of xy is x square minus 2xy. Now we find f of tx comma ty. That means instead of x everywhere you just put tx, so this will become tx square minus 2 tx into ty, right? What are we getting? T square x square minus 2t square xy. This is again nothing but t square common and x square minus 2xy. Now this is homogeneous function of what degree? Now see, combined power of x and y is 2 in every term. If you look over here, cumulative or combined or total power of x and y in every expression is 2. Here also x and y's power is 2. Only x is there, y is not there, so power we can call as 2. Here x and y are there. Cumulative, that means summation of powers. Power of x is 1, power of y is 1. So total power is 2. Correct. Here also the same thing. Here also the same thing. So that is why t square came out to be common. Right. So this is homogeneous function of degree 2. Homogeneous expression of degree 2 you can say, or function of degree 2. Both are okay. Now over here f of xy, just put f of tx comma ty. Right. Now before doing this, just see what is the cumulative power in every term for x and y. Here x and y 2 plus 1 3. Here only y is there, x is not there, so sum is 3. Here x square and y 2 plus 1 3. So this is homogeneous expression of degree 3. Simply here also same thing will happen. If you put instead of x you put tx, and instead of y if you put ty, t cube will come out to be common. You can see also ty cube plus tx into ty square. Now if from every term t cube is coming out common, from here also t cube is coming out common, this will become t square x square into ty, so 3t cube will come out to be common, and x square y will remain as it is. Here also t cube will come out to be common, and x square remain, y cube remain as it is. T cube will come out to be common, xy square remain as it is. Correct. So why is t cube coming out common? That the reason is that the total power, the cumulative power is 3. Cumulative power of x and y is 3. That's the reason. Special approach is used for finding the solution of equations involving such type of functions which are homogeneous. So that is why we need to know what is the meaning of homogeneous first. Right. Here also we can see if you put tx, if we find f of ty comma or tx comma ty, tx comma ty. Now what is the cumulative power? Y by x, 1 minus 1 0. Power is getting cancelled. Here they were multiplied. Here it's division. Y by x 1 minus 1 0. Here 2 minus 2 0. So yes, total power is 0 for y by x. So it should be a homogeneous function, and we can check with tx and ty also. If we put ty instead of y, ty square upon tx square plus sine of ty by tx. Now t will get cancelled everywhere, right? So same function will be obtained. Cumulative power is 0. So you'll have to, if you want to check for homogeneous expression, instead of doing this tx ty, you can just look for the cumulative or the total power of x and y in the expressions. Alright, a differential equation of the form dy by dx is this. Yeah, this you understood, right? Homogeneous differential equation. A differential equation of the form f of xy upon g of xy, a function of xy and a function, not xy multiplied, x and y both are there, and in denominator also you have a function of x and y. These type of expressions we generally check for homogeneous equation, and in these if we find that the degree of x and y cumulative couple is equal in numerator and denominator both, then we call it a homogeneous differential equation. What is the working strategy? Now in dy by dx is also a differential. In dy by dx, if we have a homogeneous equation, then also it's possible in dx by dy. If we want a homogeneous equation in dx by dy, then we'll have a function of, we'll have to create a function of x by y. How will we create? We'll divide the numerator and denominator with the same power of x or y. With the same power of x or y. For example, the equation is reduced to this form. If we want a homogeneous differential equation in dy by dx, then just create a function of y by x. It can be y square by x square, y cube by x cube, only y by x, something like this. How will you create that? By dividing by x or by y's. X square, x cube, x to the power 4, or y square, y cube, y to the power 4. So basically from the function which you get, in that try to create a function of y by x, right? So, and then you can take y by x equal to some t, right? We'll understand with the help of a question. So here if you see whether it's homogeneous or not, power of x is 2, power of y is 2. Here we have xy, but we can write it like this, na? Dy by dx equal to x square minus y square divided by xy. Now in each term check, what is the degree of x and y both? 2. What is the degree of x and y both? 2, because here x is not there, here y is not there. In the denominator, what is the degree of x and y both? 2. So it is a homogeneous differential equation, and we can find the solution of it by just creating y by x. So divide by x if you want, divide by x or divide by x square. Best is dividing by x square. So x square by x square minus y square by x square, here xy by x square, right? This we can do. So what will this become? This will become 1 minus y by x whole square divided by y by x. Now just take your y by x equal to some v, and y will become your vx, and then differentiate on the both sides. This is the approach which you should use for homogeneous differential equation, or if you see a homogeneous differential equation in this case, these type of cases. Now there is nothing, now there is just integration which we are going to use. Dy by dx, your dy by dx will become v plus x dy by dx, x dv by dx, sorry, x dv by dx, right? This is going to happen. Now substitute over here dy by dx, over here only v plus x dv by dx, over here we are substituting, will become equal to 1 minus v square divided by v. And now it's just, now you can achieve the variable separable form very easily, correct? So if v will take that side, so 1 minus v square by v minus v it will become, so we are going to have x dv by dx, 1 minus v square by v minus v will give us 1 minus 2v square divided by v, correct? That's it. Now you can integrate for the further thing. So with dx by x on the right side and v by 1 minus 2v square dv on the left side, so this will become v by 1 minus 2v square dv, and this side we'll have dx by x. So right side to is easy, rest of the thing we can easily do. This is just about integration now, right? Integrate both the sides and you will get an expression. There again substitute y, v, there again resubstitute v, whatever you got for v, again you'll have to resubstitute it. So let's say this will become the integration of v to 4v. We have its differential in the numerator, so we'll substitute substitute this as t, and we'll get 4v. So minus 4v, so minus 1 by 4 will have to divide over here, although this you can do on your own, but 4v by minus 4v by 1 minus 2v square equal to dx by x. So this will be just ln x plus c, and then this will also become 1 by 4 ln of 1 minus 2v square, 1 minus 2v square, ln of 1 minus 2v square, this will become, and this side will have ln x plus c. Just substitute v back again and you'll get your answer. Let's see if they have, yes, this is what we are getting, minus 1 by 4 log of 1 minus 2v square, and right side log of x plus c. Again substitute v as y by x, and this will be your solution for the differential equation. That simple it is with a homogeneous differential equation. Now here do we have a homogeneous differential equation? Let's see. What is the total power of x and y in each term? Each term you have to see. See, there is a square root. So 2 by 2, this is the power is 1. Here also power is 1. Here also power is 1. Here also power is 1. So most of the times you have to see like that. For example, here if you will see dy by dx, what will be your dy by dx? It will be square root of y square plus 16x square plus y divided by x. Power of xy in each term, coupled in each term, is just 1. Here also square root is there, square root of square will give you 1 power. So 1 power, 1 power, 1 power, 1 power. Everywhere in each term, numerator and denominator, total power in each term is 1. So directly and otherwise you have the normal approach, substitute y as ty, x as tx, and then do. So if you substitute ty over here, tx over here, right? So t square will come out common, and what will come out of square root? T will come out. Here also ty, so t will be taken common. Here also tx, t and t will get cancelled, you'll get the same function again. So that's why quick way of thinking is cumulative power or total power of x and y in each term. Right, that is one way in which you can check whether it's homogeneous or not, and if it is homogeneous, then the approach is very easy. There is nothing to do, right? Dy by dx is this. So now what will you do? You'll divide by x, right? You'll have to create a y by x function over here, na? So what will you divide with? We can write like the, here only we don't have to even write like this. One more thing which we can do, dy by dx minus y by x, right, equal to, here divide everything by x, right? This divided by x, this divided by x. Right side also we can do this. So this will become y square by x square, square root mein y square by x square plus 16, simply, right? Then substitute y is equal to tx, or we are using vx, so no problem, vx. Your dy by dx will become v plus dv, x plus v dv by dx, x plus v dv by dx. Correct. So your dy by dx minus v equal to square root of v square plus 16. This is standard integral you are getting over here. Correct. So dy by dx we have taken already. What is our dy by dx? Dy by dx is x plus v dv by dx. Something wrong. Right. x plus v dv by dx or v plus x dv by dx. Arey, ulta we have done. Sorry, x v plus x dv by dx. Right, ulta we have written na. So that's what v plus x dv by dx. Instead of dy by dx, I've just put this and minus v equal to square root of. It's getting cancelled. That's very good. Right, it's getting cancelled only. V is getting cancelled only. We are directly getting our variable separable form. So this will become dv upon square root of v square plus 16, which is a standard integral, and equal to dx by x. Directly we are getting. Not a problem at all. This is our ln of v. This will become 1 by square root of a square plus b square. No? So ln of a plus this thing, right? So it will be ln of v plus square root of v square plus 16. This side we are going to have ln of v plus square root of a plus square root a. So v square plus 16 equal to, this will just become ln of x plus c. And then there are some other things. Y of 1 is given equal to 3. So you can substitute 3 comma 1 and find the value of c. But before that, v also will have to resubstitute. So this will become, v was y by x. Okay, so if we'll substitute, what are we going to have? Y plus y square. This will become y by x. Y by x, this y square by x square. So this will become nothing but y plus square root of y square plus 16x square, right? Y will get cancelled this side, and this side will have cx square, right? Ln of x, this instead of c will take ln of c, right? In constant we take in ln only, no, so that we can convert everything up. Okay, the resubstitution will give you this. Now put 1 and 3. Right, y of 1 is equal to 3. So y as 3 and x as 1. Right, y as 3 as x and x as 1. So 9 plus 16, 25, 5 plus 3, 8 you will get. X square equal to, x as 1 na, so c equal to 8 you will get. C equal to 8 you will get. Put y equal to 3 and x equal to 1. So 3 plus, this will become 9 plus 16. That means 5 plus 3, 8. X is 1 already, so c you'll get equal to 8. Now what are they supposed to find? Y2, y of 2. So put x equal to 2 and find y. Right, y plus square root of y square plus 16 into 4, 64 equal to 4c, 4 into 8. Now just square both the sides and you can easily get. This will give you, let's check the answer. 15 you'll get 15. Right, value of y you have to get over here. That's what it is asking. Y of 2 it is asking. So put x equal to 2 and find the value of y. C we already got as 8. Okay. One more, this here also it looks horrible, but see, this is a function of y square by x square. This is another function of y square by x square. Not function actually. F dash this is f dash. And here it's already given in the homogeneous form. The equation is already given in the homogeneous form. We don't actually have to do anything over here. Can you see that? It is already given in the homogeneous form. Everything over here is already given in the homogeneous form. So we can directly take y is equal to vx, y by x equal to v, or y equal to vx. So our dy by dx will become nothing but v plus x dv by dx, and here y, we can directly substitute or take this y over here or bring this x, bring this x over here, then y by x dy by dx it will become, na? Y by x dy by dx means v dy by dx, right? So v, this x will come this side, right? This x will come this side. Y by x into dy by dx will become v into dy by dx, which is v into v plus x dv by dx. equal to, so this x has already come this side, this will become v square plus function or phi of v square divided by phi dash, it is f dash, it is derivative of the function is given there. So phi dash, okay, let's take phi dash only, phi dash of v square again, right? Okay, now we'll have to just arrange this side v square we are getting, this side also v square we have. So v square is getting cancelled. Now x, okay, one v will come this side also. Okay, v, nahi, wait. V will get cancelled. Both sides v will get cancelled. Okay, vx will put, no problem. This side what we'll get, vx, see this v square and this v square will get cancelled. So vx dv by dx equal to, let's write one more step, no problem, phi of v square, phi dash of v square. Now we can integrate on both sides, right? Because v dv we have and x by dx we have. So first let's achieve variable separable form, which will be v dv by, and here we'll have into function of v phi dash v square divided by phi of v square. Okay, this side we have dv and then this side to dx by x. So now we have achieved variable separable form. This step, can you see? After this will become variable separable now. All the v functions are with dv and x with dx. Okay, all the v functions are with dv and x functions are with dx. But now what to do with this thing? Acha, f dash by f, integral both the sides, f dash by f, right? We have f dash by f, so ln of f dash it will directly become, right? Ln of f dash, it will ln of function, not ln of f dash. This is, here we are getting f dash by f, right? In integration this format, so its integral will become ln of f directly. But this 2 is a problem. So but yeah, differential of v square will be 2v, so we can divide and multiply by 2. 1 by 2 we can do this, 2v phi dash v square divided by phi of v square, right, equal to dx by x. Now this is 1 by 2, this thing will become v dv and f dash by f we have. So this is going to become ln of phi of v square, correct? And this side we'll have ln x plus some constant c. This is, so you'll have to integrate, right? I'm directly writing this step, but you can integrate, right? If you need, you can revise this particular thing, f dash by f, right? I hope if you know integration, then you must have got y divided and multiplied by 2, because 2v dv is this, 2v dv is sitting over there. So now, but yeah, ln x plus ln c first of all, right? Ln x plus ln c, so this will become xc on this side, xc whole square, and ln, what do we got? Y of 1 is equal to -1, so -1 comma 1 we have to put. All right, so this will simply become no square root of phi of v square equal to cx. This 2 will go that side squared, and this side it will become square root. Ln will get cancelled. This 2 will go with xc. This 2 will go over here, 2xc, ln of xc, square it will become. Then xc whole square is equal to phi v square will come. Lns will get cancelled. So cx whole square is equal to square root of 5v square. I'm directly writing this step. Now substitute this thing, v square. What is our v square? V was y by x. V was our y by x. So v square, that means phi of y square by x square we have, equal to c square x square, again directly, right, equal to c square by x square. What if they asked, acha, y of 1 is equal to minus 1. So 1 comma minus 1, if we satisfy over here, 1 comma, nahi, minus 1 comma 1. 1 comma minus 1, minus 1 comma 1, minus 1 comma 1. Right? Nahi, sorry. 1 comma minus 1, correct. 1 comma minus 1. X is 1, y is minus 1. When x is 1, y is equal to minus 1. So that will satisfy. What do we get from there? Phi of 1 equal to c square. Right? Phi of 1 is equal to c square. So I'll write phi of 1 we are getting equal to c square. Now what are we supposed to find? Phi of y square by 4. Okay, they've just taken value of x equal to 2. So phi of y square, if you take x equal to 2, this will become 4, and c square into 2 square, that means 4c square you'll get. 4c square. 4c square you'll get. And your c square is phi of 1. So phi of y square by 4 will be equal to 4 into phi of 1, which is option B. That's how you can solve this easily. So integration obviously is going to play the major role in all these questions, all the concepts of differential equation. We need to have a strong hold on integration processes first. Now sometimes, let's see example of reducible. Yeah, sometimes you can even reduce some differential equations into homogeneous form. So most of the times you will be able to see that, acha, this is in homogeneous form, this is a homogeneous expression, and I should solve it by taking y by x equal to v or x by y equal to v and go that way. But sometimes you can even reduce the given differential equation into homogeneous form. For example, linear, and just write somewhere over here, whenever you see linear by linear, if you see linear by linear anywhere, then you must understand that either it will already be in homogeneous form, or you must be able to reduce it into homogeneous form. Right? Either it will always be in, or already be in homogeneous form. If you see linear by linear on the right side, then you must know that either it will already be in homogeneous form, or you will be able to reduce it into the homogeneous form, homogeneous expression. How to reduce it, that we'll learn, that we'll see. So there is a standard method here also. Basically I want to reduce it to homogeneous form. Suppose this 5 was not here, then this was homogeneous. This 5 and this minus 1 was not here, then this was homogeneous, right? But right now 5 and 1 are here. So what to do? Simply what I'm going to take, x I'm going to take is capital X plus h, right? And y I'll take as small y as capital Y plus k, right? And I'll substitute it over there, right? I'll substitute the same thing over here. So my dy by dx will become capital X plus h. I'll write the whole thing, plus h. Instead of small x I'm putting minus 2 into capital X plus h plus 5 divided by 2 into capital X plus h plus capital Y, acha, sorry, y, here also y plus k, y plus k plus y. Here I'll take capital Y plus k minus 1. Now this is nothing but x minus 2 capital Y plus h minus 2k plus 5 divided by, here I'll have 2 times x plus capital Y plus 2h plus k minus 1. Right, this is what I'm getting. Now what did I say in the starting? That if you didn't have this part, plus 5 and minus 1, it will be homogeneous. Here also, if you pay attention, if you don't have this part, then it will be homogeneous. So make this part equal to 0 and find the value of h and k for that aspect, right? Make this part only equal to 0. For example, I'll put h minus 2k plus 5 equal to 0. This is stopping me for making this entire equation as homogeneous. So I'll make this part equal to 0. That's it. So h minus 2k plus 5 I'll put equal to 0, and I'll put 2h plus k minus 1 equal to 0, and I'll find the value of k and h over here. So 2h cancels, 4k minus 4k minus k minus 5k, it will become 10 plus 1, 11 it will become. So we are going to get 11 by 5 for k. K will become 11 by 5, and your h is going to become 3 by 5. So yeah, h will come out to be 3 by 5. So these are the values of h and k I'm getting. So that's what I'm going to substitute over here again. For h equal to 3 by 5 and k equal to 11 by 5, this equation will be true. I'll substitute h and k as 3 by 5 and 11 by 5 again over here. Right? But you don't have to put exactly right now. You solve it assuming that we have achieved the homogeneous equation. So homogeneous equation means x minus 2 capital Y divided by 2x plus y. Right? I took these as 0, capital Y, capital Y. Capital Y you have to take. My small y and capital Y, you won't be able to make much of difference. So this part I'm assuming that it is equal to 0. I'll solve it in a way I would solve a homogeneous expression only. So this will become y square. Let's just see what is the homogeneous equation becoming. Y square plus 4xy minus x square. Capital Y square plus 4xy. Capital Y square. When you solve it in a way which we solve homogeneous expression, we'll have y square plus 4xy minus x square equal to c. This will be my solution, and here just substitute back the things again. Your capital Y was y minus k, right? Capital X was x minus h. So instead of y we'll put instead of y we'll put y minus k, small y, minus 11 by 5 whole square plus 4 into x was capital X was small x minus h, so x minus 3 by 5, again y minus 11 by 5 minus x square, that means x minus 3 by 5 whole square equal to c. This will be your final solution. Substitute back the things again over here. Right, this is how you solve when you don't have a homogeneous expression, and most generally for linear by linear you can do this approach. For linear by linear you can always use this particular approach. In mains also you can see a question like this. Now here you can, right, here it is going to be homogeneous. Linear by linear we have, but if we didn't have minus 2 then the problem would be sorted. If we didn't have minus 2 then we could solve it in the way we'd solve homogeneous expression. So instead of doing so much process that small x is capital X plus h and small y is capital X plus y, we can assume that the final equation which we are going to get will be x plus y upon x minus y, right? And so start from here only. dy by dx equal to capital X plus y, directly start from here, divided by capital X minus y. So what are we going to have? Dy by dx. How do we solve? Divide by x everywhere. So 1 plus y by x, 1 plus capital Y by x you'll have, and 1 minus capital Y by x you are going to have. When we'll solve, what will we get? Tan inverse, I'm directly solving. So what the y by x with y by x with y by x, y by x equal to v. Let me see. I'm sure that solution must be, solution is not there. tan, wait, must be there. Tan should come, yeah, tan inverse ln and x. All right. So on solving this, just solve it with the homogeneous way. I'm just saving a little bit of time. Tan inverse y by x, you are going to get, capital Y I'm putting, y by x you are going to get minus half ln of 1 plus y square by x square, right, equal to ln of x plus c you are going to get. Right. Now substitute the things back again. So what did we take? We took y, we already took, right, our h plus k, like over here if we take small x as capital X as small x minus h, capital X as small x minus h, and capital Y as small y, capital Y as small y minus k, right? Then then my h plus k minus 2 will be equal to 0, right? If I take over here, then my h plus k minus 2 will be equal to 0, h plus k minus 2 will be equal to 0, and my h minus k will be equal to 0. Second equation will be small h minus k will be equal to 0. Solve differently. You know, if you take like that, these two equations you will get, and find the value of h and k directly from here. H equal to k, so 2k, 2k minus 2k will be equal to 1, h will be equal to 1 comma 2 you are going to, no, 1 comma 1 only we are getting, na. 2k equal to 2, so k equal to 1, h also equal to 1, right? H and k both are equal to 1, right? When substitute, what happened? Tan inverse of y by x, capital Y by capital X. Now here, instead of doing anything, just put Sayadazan. Who's Sayadazan? Who is Sayadazan? ध्रुव धागड़. Sayadazan को जेल भेजो. Are you on dharna or what? Okay, now this will again become tan inverse. Now what do we have? We already have this. This will become tan inverse of y minus h, y minus k, that means y minus 1, x minus h, that means x minus 1, minus half ln of 1 plus y minus k whole square, y minus 1 whole square upon x minus h whole square, that means x minus 1 whole square, equal to ln of x minus 1 plus c. This is what we are going to have. Okay. Now what are they saying? Point 2 comma 2 satisfies it. 2 comma 1 passes through 2 comma 1. So y1 x2 1 minus 1 0. This will become 0. This will become 1 minus 1 0, 1 plus 0, ln of 1 0 again. This will become ln of 2. नहीं, ln of 1 only na. X is also x minus 1, so x is 2, 2 minus 1, ln of 2 plus c. So your c will be ln of 2, I think. C will be minus ln of 2. Right, c's value you will get, and then you have to find k plus 1 comma 2. To satisfying this. 2 comma 2 satisfies this, no? So everything is becoming 0, I think. 0 plus, this will become 0, 0 minus 0 equal to 0 plus c. So here c is coming out to be 0. And this will also become 0. 2 minus 1, 1, ln of 1 is 0, 0, 0, 0. Everything is becoming 0. C should be equal to 0. Now ln of k plus 1 comma 2. X should be k plus 1 and y should be 2. So k plus 1 minus 1, 2 minus 1, 1 upon k plus 1 minus 1, 1 upon k. So this will become tan inverse 1 by k equal to, here what we are going to have, a ln of 1 plus 1 by k square. This will become minus half ln of 1 plus 1 by k square minus 1. 1 by 1 plus k square. Sorry. Yes. Equal to ln of x minus 1. So k plus 1 minus 1. That means ln of k plus 0. Ln of k plus 0. Oh, okay. C is 0. For k greater than 0, yes, ln of k, we have done correct only. Ln of x minus 1, that means k plus 1 minus 1. This is also correct, ln of k only. So tan inverse, which would be the answer? Tan inverse 1 by k equal to ln of k. Acha, this half we can shift over there. It will become 2 tan inverse 1 by k. Right, 2 will shift over here, so this will become k square. K square minus 1 by k square minus 1. I think A should be the answer. Let's check. A is the correct answer. Right, A is the correct answer. Here we are taking LCM, so 2 will go with tan inverse. Then 2 will go on the right side, so it will become k square. Right, k square equal to this entire thing, log of k square plus 1. This will go that side and it will become k square plus 1, k square plus 1, and 2 tan inverse 1 by k will be on one side. Option A. You can solve the last part and check that we are getting this. Okay, so this is what we call homogeneous, or we can reduce linear by linear to homogeneous also. Like linear by linear, we can reduce to homogeneous. Now next thing, a differential equation is set. What is linear differential equation? Something is called linear differential equation. Let's read first. A linear differential equation is said to be linear if the dependent variable and its derivative occur in degree 1 and are not multiplied together. Dependent variable and its derivative occur in degree 1 and they are not multiplied also together. Let's take a few examples to understand how we do this. Now, this is a linear differential equation, means with y there should be dy by dx, with x there should be dx by dy. Dependent variable means here, for example, in this one we are talking, so wait, over here only. So y and dy by dx is there, suppose. So for this one, our dependent variable and its derivative are, dependent variable is y, its derivative is dy by dx. So this is linear in y. Right, now here I can have anything, here also I can have anything, xy something, x square, x cube something I can have, here also multiplied something can be multiplied, but only y and dy by dx should be there. It should not be y square then. Right, the degree of dependent variable and the derivative of dependent variable, the degree of these should be equal to 1. That's linear differential equation. Some examples are there. For example, here y and dy by dx. Apart from this, x square, anything can be there. But y should be in degree 1 and its derivative dy by dx should be in degree 1. For example, over here if we see, dy by dx is there, y is there, and y into x is there. This is, with y we have multiplied something which is x, no problem. But this is linear in y. This is linear in y. This is also linear in y. With y, there is y and there is dy by dx. Both degree is 1. With dy by dx, something is multiplied. With y, something is multiplied. But this is again linear in y. This is linear in y. Now over here, with y, there is dx. With x, there is dy. Acha, let's divide by dy. So let's say this is dx by dy. This here also dy. Here also dy. What will we have? We'll have y dx by dy minus x minus x, okay, plus log y. This is not linear because degree of y is with log. Y is not linear here. Y is with log. So first of all, this is not linear in y. And dx by dy here we have. Here we have dx by dy. So in y definitely it's not linear because y is inside log. Is it linear in x? We have x and dx by dy. X is degree 1, dx by degree 1. Here y is multiplied with dx by dy, no problem. So this is linear in x but not linear in y. Sir, we could also divide. Divide by dx. Let's check dividing by dx. It will become y minus x dy by dx, and here we'll have log y dy by dx. Now see, y is degree. Y is with log, na. So anyway, if y is with log, anyway it is not linear in y, right? So it is linear in x though. Now check over here. Ln y dy by dx not linear, definitely not linear. Why? Because y is in log. Here y square is there, dy by dx is there, x square is there. Y square, the degree of y is 2, not linear, right? Not linear. This one definitely linear. Why? Because dxy dy is there, x is there, so this is linear. X and dx by dy is there, both degree is 1. Tan inverse y with y I don't care, right? So this is degree 1. This is dy by dx. How is this linear? Y to the power x we are getting, yeah, something like that. How is this is linear? First one okay, pakka. First one okay, correct. Not a problem. This is dy by dx is equal to 1 by x ln y. Acha, in x it is linear. Yes, in x it is linear. In x it is linear, na? Wait, this is dy by dx equal to 1 by x ln y. Correct. If we find dx by dy, so dx by dy will become x by ln y. Right. Now with x, 1 by ln y is multiplied. But this is still linear in x. X's degree is 1 and dx by dy's degree is 1. This is linear in x. This is linear in x. Right. This is not linear because dy by dx and degree of y, and we cannot convert also it in x also. This is definitely not linear, but this is linear in x. In y it is not linear because y is there with ln. But if we reciprocal, then yes, we have this minus, obviously minus 1 by x, not a problem. So this is how we check whether we have a linear differential equation or not. And there is a standard method to solve the linear differential equation. The method is very much defined. There is a simple formula: y into integrating factor equal to integration of q into integrating factor plus c, right? Y into integrating factor is equal to integration of q into integrating factor. Now what is p and q? If your equation is linear in y, then it will be of this form: dy by dx plus something multiplied with y equal to q. This can be a function of x or anything else. This p will be some function not in y but some function in x, right? So p equal to dy by dx plus ty equal to q will be a linear equation in y. In x if you have, then it will look like this: dx by dy plus p of x, not p of x, p is some function of y into x plus q. So p and q both will be, in this case when the linear differential equation is in y, then your p and q will be the functions of x, and when your linear differential equation is in x, then p and q will be the functions of y. Okay, this is going to be the case. Now solution is given by simple. In this case solution will be x into an integrating factor equal to integration of q into integrating factor dy by plus c, and in this case we are going to have y into integrating factor equal to q into integrating factor dx plus c. This is how you are going to simply get the solution as a solution of your differential equation. You won't have to do anything in this case. For example, we'll see some examples also over here. For example, this is the case, dy by dx plus 2x by 1 plus something something. So this is a linear differential equation in y. So first of all, we'll find integrating factor, right? Integrating factor is e, acha, this I didn't tell you. Integrating factor is your e to the power integral of p dy. And here also same thing. If your linear differential equation is in x, sorry, linear differential equation is in y, then your integrating factor will be e to the power of integral of p dx. If your differential equation is in x, then integrating factor will be e to the power integral of p dy. So here our differential equation is in y. Our integrating factor will be equal to e to the power integral of p, which is the coefficient of y. So p is 2x by 1 plus x square dx. Obviously you can see dx and dy not need to get confused because this will be in x. If it is a differential equation in y, then p will be a function of x. So this is going to be your this will become e to the power ln of 1 plus ln of 1 by 2 also will come, na? 1 plus x square directly. Acha, 2x is coming. Yeah, 1 plus x square. 1 plus x square. This will be your integrating factor. Now equation is in y. So y into integrating factor equal to integration of q into integrating factor d of x plus c. So what is y? Y is your, okay, simply y into e to the power of ln of 1 plus x square equal to integration of q, which is 1 by 1 plus x square whole square into integrating factor, which is your integrating q into integrating factor, yeah, this thing only, e to the power ln of 1 plus x square mod dx. E to the power ln means this is also e to the power ln will become again same thing. This will become ln of 1 plus x square only. Sorry, not ln also, only directly 1 plus x square is going to come. Directly this will just become 1 plus x square. E to the power log of 1 plus x square base e. Ln means base e. So same, bhai. A to the power log of b base a will be equal to b, na? This is the property of log. That's why I'm writing that. Right? Directly integrating factor will be nothing but your 1 plus x square only. So this side also y into 1 plus x square. This side, this will become 1 plus x square. So 1 will get cancelled. One of them will get cancelled. Integration of 1 by 1 plus x square you'll have dx plus c. So this is just going to become y into 1 plus x square equal to, this is tan inverse x plus c. Correct? So this is how directly you'll get the solution of your differential equation if it is linear differential equation in x or y. This also you can solve similar way. This is a linear equation in y again, right? So your p is this and this thing is this. Dy by dx will become this is dy by dx plus y into, you'll have to create, right? Something is multiplied with dy by dx. So first convert it into dy by dx plus py equal to q, right? So p will become 1 by 1 plus x square in this case, and q will become tan inverse x by 1 plus x square. Simple. Your integrating factor will become e to the power p dx, where p is what? 1 by 1 plus x square dx, which will be e to the power tan inverse x. You can check this similar question this is. So your general solution will become y into if, integration of q into if dx plus c, which is this. And finally after integrating you are going to get this. You can check the solution. Same last type of problem, only just integration is different, right? Same type of problem, just integration is different. Here again this is dy by dx plus y upon 1 plus e to the power 2x equal to 1 by 1 plus e to the power 2x. This got converted into linear differential equation in terms of y. right? This is converted into linear differential equation now in terms of y. What is your p over here? P is just wait, ulta, something wrong I did. This is dy by dx plus y equal to 1 by 1 plus e to the power 2x. This entire thing will go. P will become equal to 1 and q will be equal to 1 by 1 plus e to the power 2x. Integrating factor will be easier in this case. E to the power integral of p dx, that means 1 dx, right? Integral of, right? So e to the power x only will become your integrating factor. Now y into integrating factor, that means y into e to the power x equal to integral of q, that means 1 by 1 plus e to the power 2x into f of x, sorry, q into integrating factor, that is e to the power x only dx. This will be your solution. So e to the power x upon 1 plus e to the power 2x. This you'll have to integrate, which will become tan inverse of e to the power x only, yeah, e to the power 2x. No? Integral of e to the power x will become e to the power x. So differential of e to the power x. Wait. Integrate this. This will become y e to the power x. This will become tan inverse of e to the power x and plus c. Now what are they given? Passes through the point 0 comma pi by 2. So 0 comma pi by 2, that means x is 0. E to the power 0, this will become okay. This will become tan inverse e to the power 0 plus c equal to pi by 2. So c will directly come equal to tan inverse 1. That means c will come out to be equal to pi by 2. Right, 0 comma pi by 2, if we satisfy over here, what are we getting? Pi by 2, right? Equal to pi by 4 plus c. Right? E to the power 0, this will become 1. Y is pi by 2. And tan inverse e to the power 0, tan inverse 1. That means pi by 4. Right? So pi by 2 minus pi by 4 equal to c, which is pi by 2 only. Right? So c will come out to be pi by 2. This will become pi by 2. Y is pi by 2. Right? I hope you'll get it. Just try once on your own. Tan inverse 1 will become pi by 4. And pi by 2 minus pi by 4 will become pi by 2. Correct. So c is pi by 2, pi by 4. Sorry. Pi by 2 minus pi by 4. Pi by 4 it hoga. Haan, pi by 4. Pi by 4. Alright. And this we are supposed to find now. Then limits here a little bit we used. Limit of x tending to infinity e to the power x y of x. Y of x. So limits extending to 0, it will become e to the power x into y. That means e to the power x into y. Y at x. Wait. Wait. E to the power x into y of x will become what? E to the power x into y of x. That means y e to the power y, x into y. E to the power x. E to the power x y of x is same thing only, na? E to the power x into y of x. That means here we have to put, in this we have to put y of x. E to the power x into y of x. E to the power x into y will be nothing but tan inverse e to the power x plus pi by 4. This thing only. E to the power x into y at x. They are asking us to find. So e to the power x says e to the power x into y is this expression. So e to the power x into y is this expression. At x, they want us to find the expression. Here only we can take limit tending to infinity. Right? So limit x tending to infinity at e to the power x y will become infinity over here will give us pi by 2 and pi by 4. Pi by 2 plus pi by 4. That is 3 pi by 4. Direct answer we are getting. That will become 3 pi by 4. Okay. Here again same type of question. Dy by dx will be equal to y by x plus 3y square. Acha, can we do this? No. First, no. We cannot directly do this. X dy by dx, this is no problem. Plus 3y square dy by dx equal to y we are getting. This is linear in what? In y it is not linear for sure. In y it is not linear for sure because y square is coming. So is it linear in y? Can we say that it is linear in y? Just think about that. We cannot say, right? It's linear in y. So we'll divide by y. It will become x by y plus 3y equal to dx by dy. Right? Wait. Divide entire equation. This equation if we divide by y, it will become x by y plus 3y. Correct? Dy by dx equal to 1. So this thing only we are getting, no? X by y plus 3y. Y square kahan se hai? 3y plus 3y dy by dx equal to 1. Now we can say. So x by y plus 3y will become equal to dx by dy. This bracket. So x by y plus 3y will become equal to dx by dy. Now this should be linear in x. Now it is linear in x. It is linear in x. Not a problem. This equation is linear in x. Here our p. What will be our p? Our p will be equal to 1 by y. 1 by y will be your p and q will be equal to 3. Correct? P is equal to 1 by y and q will become your 3y. Now you can apply the same approach, but this time x into integrating factor will be equal to integration of 3y into integrating factor dy. Right? Just approach will be a little bit different. I'll show you if they have. This is okay. Minus 1 by y. We didn't put kya? Minus 1 by kaise? Achha, this x by y will go that side. That's why. X by y will go that side. We'll have to convert it into this way. We'll have to write it in this way. Minus 1 by y x equal to 3y. So your p will become minus 1 by y, q will become 3y. And integrating factor will be e to the power of integral of p dy, which is minus 1 by y dy. And this is the way you'll have to solve. This will be your differential equation in this case. X into integrating factor, integration of integrating factor, q dy plus c. This is how you'll have to do. Okay, and then x into 1 by y will be equal to 1 by y 3y dy plus c. Correct? This is sahi. 3 into integration of dy plus c. What else is given? Anything else? Nothing else. Achha, they wanted equation only. This will become your final equation. Solve these once on your own using your integration techniques also. Equations which are reducible to linear differential equation. if you have f of y with py and f dash of y with dy by dx, in this case we can say that this type of particular equations are reducible to linear differential equations. Just a minute. Yeah, I was saying that if you have with in the function of y, here with p you have a function of y, this is going to be a linear equation. In, suppose generally it will be dy by dx plus p y equal to q, something like this. But in this case, instead of y over here we have a function of y, and here the derivative of this function is sitting with dy by dx, right? The derivative of this function is sitting with dy by dx. I'll show you an example. For example, like this, right? This is linear in y, but with y, with y over here we have tan y, instead of y we have tan y, right? And this should have been a linear, this looks like a linear, but here we have a function of y, and here also we have a function of y. With dy by dx we have a function of y, and with p, which is x, 2x over here, there also we have a function of y. But one catch is there, that derivative of this is this. If we find this is f of y, then f dash of y is sitting over here. In this case, just substitute your f of y as some function t and simple substitution, right? Simple substitution, that way also you can approach. For example, over here only you can see cos x we have over here, and here we have cos y, right? This should be linear in, this should have been linear in y, but instead of y over here we have a function of y which is e to the power sin y, and integration of the derivative of e to the power sin y will also be e to the power sin y into cos y, right? If we take e to the power sin y by dy, if we find by dx, if we find, right, there if we find the derivative of e to the power sin y, it will be e to the power sin y cos y, right? E to the power x, and derivative of sin y will become cos y. So this is sitting over here, this is of the same form that we are talking about. I hope you get my point. So in this case also you can use the linear differential equation concept only, but just little bit of catching you'll have to do. You'll have to see it very clearly and fastly, that derivative of e to the power sin y is sitting with dy by dx, which is the case over here, correct? So if you take e to the power sin y as some t, then e to the power sin y cos y will become your dt. This will become your dt by dx. Cos y dy by dx, obviously. Here cos y dy by dx will become your dt by dx. So this entire equation will become nothing but dt by dx. This entire thing now e to the power sin y cos y dy by dx will be dt by dx plus t cos x equal to cos x. This is linear in t. This is exactly linear in t. T cos x equal to cos x. This is exactly linear in t. You can find integrating factor over here. Your integrating factor will become e to the power integral of cos x. Integral of cos x. So it will become e to the power minus sin x. Or minus e to the e to the power sin x only. This will become e to the power sin x only. Right? This will be your integrating factor. And now t into integrating factor, t into e to the power sin x equal to integral of q, that means cos x, into integrating factor, that means e to the power sin x dy dx plus c. So this is becoming t e to the power sin x equal to e to the power sin x only is coming again, no? Sin x only will come again. Cos x into, this is a product rule if we will apply. So cos x into e to the power sin x plus minus sin x into e to the power sin x. This will come right. Minus sin x into e to the power sin x. So finally, eventually we'll be left with e to the power sin x only. This will just become e to the power sin x only. So t into e to the power sin x equal to product rule, cos x into e to the power sin x minus sin x into e to the power sin x. So this will become cos e to the power sin x only, e to the power sin x and plus c. Now what is given? 0, 0 we can satisfy. So t equals to sin 0 1 e to the power, t equal to e to the c will become t minus c. Sin x sin y, अच्छा ठीक है. C will become 0 1, ठीक है. T equal to sin 0 0. This will also become 1. C equal to 0 only we are getting, यार. X is 0, right? X is 0, तो here sin 0 0, here sin 0 0 1. T equal to C equal to 0 only we are getting. We are getting C equals 0, right? Right, C equal to 0 only we are getting. Sin x plus sin y equal to sin x, it will become at x equal to 0, y will be equal to 0, alright. So 1 equal to 1 plus c, that means c is equal to 1, alright. Arey, but t to, yeah, t will put again, no. Here e to the power sin y, this will become e to the power sin y into e to the power sin x, okay. This entire expression we'll have to find. See, basically here t again we substituted, so c is coming out to be 0. When we put x as 0 and y as 0, both as x, when x is 0, y is also 0. So put x is 0, y is 0, 1 minus 1 equal to c, that means c is coming out to be 0. Now just we'll have to just find all these values. Y at pi by 6. So y at pi by 6 sin pi, e to the power sin pi by 6 divided by e to the power cos pi by 6. That's it. E to the power sin pi by 6 divided by e to the power sin pi by 6. Same thing, 1 only we'll get. Right, so at at y pi by 6, this will become, your y pi by 6 will become equal to kitna, y pi by 6 is becoming equal to 0 only again, right? And pi by 3 also is becoming 0, pi by 4 is also becoming 0. All of these will be equal to 0. All of these will be equal to 0. So this will be equal to just 1, right? You can find y pi by 6 also. Y e to the power value of y, putting x as pi by 6, everything will become 0 only, because sin y will come out to be equal to 1. That means y will be equal to 0. All of these will be equal to 0. You can check, all of these will be equal to 0. Now one last thing, which is exact form. Exact form, basically if you get something in your linear, in your differential equation, if you get something like this, d of xy, we know how to find d of xy. D of xy is x dy plus dxy, sorry, y dx, x dy plus y dx. These general forms we will have to remember. If we find these in any of the differential equation, then we'll have to apply them as it is. That's what we call exact form, right? Exact form. Just make a note of these, right? Most importantly, most of the times this one and this one will be used, and even this one and this one. Yeah, this is y by x, u by v method. If we apply x square x dy minus y dx, right, as it is you can apply. So if something like this you find in your differential equation, write it as dy by x directly. If you find something like this in your differential equation, write it as d ln of xy directly. If you find x dy plus y dx simultaneously in your differential equation, then write it as dxy directly, and the problem will become easier. These two rarely used, but still make a note of it. Very rarely used, but still you can make a note of it. For example, in this question, if we see, what do we have? X square, if you open it, x square minus ay dx plus y square, sorry, just a minute. This is x square dx minus ay dy dx plus y square dy minus ax dy. So if we combine things over here, x square dx plus y square dy we have, and minus a if we take common, then y dx plus x dy we have. Right? These are exact forms. X dy plus y dx will directly become dxy. Right? So this will directly become d of xy, and x square dx plus y square dy. X square dx plus y square dy. This also we can convert. Achha, this to directly will be able to integrate. No, this is equal to 0. So integrate all of these. Right? Integrating all of these, we'll get x cube by 3 plus y cube by 3 minus a will come out. This will become integration of d of xy. Right? D of xy equal to 0. So we'll have x cube equal by 3 plus y cube by 3 minus a d axy minus axy. Integration of dxy, d of xy will become xy directly. So this is why axy equal to 0. This will be our final solution. This is how exact forms will help you. In many questions you'll be able to see exact forms. Here also you can see. Right, this will become ln of y. So let's say 2x ln of y. If we, how can we convert it into exact form? Ln of y into 2x dx. Let's write it like this: ln of y into 2x dx over here, and x square by y, instead of that, x square plus x square into 1 by y dy we can write. Right, plus x square into 1 by y dy we can write, minus minus 3y square. This too no problem, 3y square dy equal to 0. Now this part, this part can be looked at in the exact form. This is nothing but d of x square ln y. This is d of x square ln y. d ln xy is this form only is written, no? What is d ln xy? X dy plus y dx upon xy. Correct? So here we have this form, x dy plus y dx upon xy. If you take the LCM also, you will get y 1 over here and y over here. So this is d of x square ln y minus this, so no problem, 3y cube by 3. So this will become y cube only. Y cube equal to 0. Integrating. Or I integrated this, and this you can integrate. So this will become x square ln y minus y cube equal to 0 directly. X square ln y minus y cube equal to 0. Okay. So one remark is written, whenever you see ln y, look for 1 by y. So 1 by y and ln y will make this form, will make the third form in the exact forms. PYQ solution for the chapter. Sir, PYQ series upload for this chapter. For this chapter, Sabrish, after conics beta, maybe in January, we'll be able to do it. Okay, this question also you can solve very easily. Exact form based question only. You can solve once, try this on your own. Here you will get y dx minus x dy upon y square. Right? Y dx minus x dy upon y square. This form you will get y dx minus x dy upon y square. This form, this exact form you are getting. This is 2019 question, very easily solved. But look for this form. Try to create this form and try to solve this on your own once. Alright then. So these were all the forms that we can expect. Sir, is it okay to skip conics for JEE? No beta, no. Don't skip conics. Conics you can, but coordinate nahi. Conics, some conics you can, but straight line circles are also part of conics. At least try to do straight line and circles. Okay. Try to do straight lines and circles completely, at least. Okay. All right then. Thank you then. Study this chapter also. And be present for the PYQ class of circles we'll be doing. Okay. All right. Bye-bye. Take care. Thank you.